joint probability density function. That means when x and y are two continuous random variables, then function of x, y is called joint probability density function. So previously it was joint probability function. Why? Because then x and y were discrete random variables. Now x and y are continuous random variable. So when x and y are continuous random variables, then function of xy is called joint probability density function if it satisfies these following two conditions. Number one is the function must be greater than or equal to 0, and the total probability of this function is 1. So if we consider one example, say for example it is given the functional form of xy is 4xy, where x lies between 0 to 1 and y lies between 0 to 1. So from here we can see the value for function of xy must be greater than 0. Why? Because x is greater than 0 and y is greater than 0. So their product must be greater than 0. So condition 1 is fulfilled. Now what about second condition? So taking their integration of the function over x and y, we have the value is 1. So it seems that it also satisfies the second condition. So therefore we can say function of xy is joint probability density function. Now what about the marginal probability density function? So similarly, if x and y are two continuous random variables, then g of x integration of joint probability density function of d of y over x is called the marginal density function of x, and similarly h of y equals to integration of function of xy dx are called the marginal density function of x and y. So if we consider the previous example to calculate the marginal density function of x and marginal density function of y, here is the solutions. How do we calculate the marginal density function of x? See, g of x equals to integration of f of xy dy. So f of xy is given as 4x and 4xy and then dy, and the limit for y is 0 to 1. So after doing the calculations, we have it as twice x. So see, now it is also in the form of a function. That's why this is called marginal density function. So finally we can write g of x equals to twice x, where x lies between 0 to 1. Exactly in the same way we can have the marginal probability density function of h of y, and it is twice y, where y also lies between 0 to 1. Now let's check whether this function shows that x and y are independent random variables or not. So to check the independent random variables, we know they are joint probability density function must be equal to the product of their marginal probability density function. So from here we can have the value of marginal density function of x is twice x and y is twice y. So if we are taking their products, then we have it as 4xy, which is equals to their joint probability density function. So therefore we can say x and y are two independent continuous random variables. Now if we consider another example of x and y, for their joint probability density function as twice y. Then we want to find out probability of x is less than or equals to half. Probability of y lies between 1/4 to 1/3. So first of all, we need to calculate the marginal density function from this joint probability density function. So g of x equals to integration of f of xy dy, whatever the limit of y is 0 to 1. So after this calculation, we have the marginal density function of x is 1. Similarly, twice y, so it's y square, right? And similarly, h of y is twice y. So this is the marginal density function. Now from here we can calculate probability of x is less than or equals to half. So see the calculation. Finally we have the value as half. Also, if you want to find out expected value of 3x minus twice y, how we can get it? So from the previous chapter of mathematical expectation, we know that we can expand it as 3 into expected value of x minus 3 into expected value of y. So what about expected value of x? It is integration of x g of x dx. So the value is half. And also expected value of y is integration of g of hy dy. So it is 2 integration of 0 to 1 y squared dy. So by using this calculation, we can have the value for expected value of x and expected value of y. And then we can put these values here and we can have the value of expected value of 3x minus twice. So I hope you now understand how we can find out the functional form of marginal density function of x and marginal density function of y. So if you have the functional form of the marginal density function of x and y, then also we can calculate the variance of twice x minus thrice y. So now it's your task to calculate variance of twice x minus thrice y.